So welcome Year 10 to our Lesson 9 for our Flipped Classroom tutorials. Now I've told you for the next couple of weeks we're going to be taking on a new topic called geometry. So today we're going to quickly look at what is called the angle sum of a polygon. Let's look quickly at what we're going to be learning for the whole chapter. Today's lesson is number 1, how to find the interior angle sum of a polygon. Lesson 2 will be how to find the exterior angle of a polygon. Lesson 3 is how to write geometrical proofs of simple shapes. 4, we're going to be looking to prove congruency in triangles. And Lesson 5 will be how to prove similarity in triangles. So, Lesson 1. Interior angle sum of a polygon. Now, I'll give you the formula already. The interior angle sum of any polygon is equal to 180 times n minus 2 degrees. Below is an example of a decagon, a 10-sided shape. So this formula is actually helping us to find the total sum of all the angles inside any shape. And I've labelled the angles in this decagon with red. And you can see a decagon, a 10-sided shape, will have 10 angles. Back to the formula. Let's quickly revise that the word sum means to add. So if I'm asking for the interior angle sum of a shape, I'm adding all of the interior angles inside it. Now looking at the formula, the other variable we need to look at is n, and n will stand for the number of sides the shape has. And in this case, a decagon has 10 sides, so n would equal to 10. So here's a bit of revision on a few shapes that we already know and a little bit of language that we need to go over. So at the very top you'll see a triangle. In the word triangle, tri means 3. Below this we can see 3 four-sided shapes which are known as quadrilaterals. We've got a rhombus, a square and a trapezium. So the word quadrilateral contains the word quad, which means 4. Now below these, I've given you 6 examples of what could be known as a polygon. We've got a pentagon, which has 5 sides, a hexagon has 6, a heptagon has 7, an octagon has 8 sides, a decagon has 10 sides, and a dodecagon has 12 sides. So below it says a polygon is a many-sided shape, and usually applies in maths to any shapes with 5 sides or more. The word poly in the word polygon simply means many. So, our purpose for the lesson is to find the interior angle sum of a polygon. And to do this we simply just use what we already know. Let's look at a triangle. We already know that the angle sum of any triangle is 180 degrees, meaning the 3 interior angles of a triangle, when added together, equals 180 degrees. So when n equals 3, n being the number of sides, the sum of the interior angles is simply 1 times 180 degrees. Now let's look below. We have a rectangle. A rectangle is a 4-sided shape. So in this case, n would be 4. But reading with me, if we divide a rectangle into 2 triangles, the angle sum would simply be 180 times 2. The angle sum of one triangle plus the angle sum of another triangle. So as we said with the rectangle, when n equals 4, or the number of sides equals 4, the sum of the interior angles is simply 2 times 180 degrees. Now look below. If we divide a pentagon, a 5-sided shape, into 3 triangles, the angle sum would simply be 180 times 3. So, in this case, when n equals 5, the sum of the interior angles is simply n times 180 degrees. So I've drawn this little chart for you, and we can see on the left hand side that we have some shapes that we're familiar with. The middle column will tell you the number of sides, or n. The last column is our calculation to find out exactly how or what the interior angle sum of that shape will be. So let's look quickly at the triangle. If n equals 3, we just learned that the angle sum would be 180 times 1. Below is a square. N equals 4, and the angle sum would be 180 times 2. We have a pentagon below it, where n equals 5. Therefore, the angle sum would be 180 times 3. So we've just been through those 3 examples. Let's look further. If we have a hexagon, where n equals 6, the angle sum would be 180 times 4. Now carefully look at this. 4 can also be written as 6 minus 2. Below this, we have a decagon, where n equals 10, and the angle sum becomes 180 times 8. And again, we can write 8 as 10 minus 2. So this may help you to understand that a side with n number of shapes, n number of sides, n would equal n for n number of sides. And if you looked at the pattern carefully, the formula to find the interior angle sum of any shape with n amount of sides would simply be 180 degrees times n minus 2. Have a quick look at the formula, or the bottom row, and see if you can actually see the pattern occurring in all the shapes above it. So let's move on. Here are some really familiar questions that you will be asked within any test or exam that you'll see. I've written the formula once again at the very top of the screen. The interior angle sum of a polygon equals 180 times n minus 2 degrees. So our first question. What is the interior angle sum of a polygon with 18 sides? We've looked at actually writing formulas and solving them. And whenever we're asked a question that has a formula, your first step is to simply write it. And you'll see on the top line, S for sum equals 180 times n minus 2. Revise quickly that S is the sum of the interior angles, and n stands for the number of sides the polygon has. So step 2, you would write your values, and you can see next to it in green I've written that n is equal to 18. That's the information the question gave us. Step 3, when you're solving a formula, substitute the values in. And we would find that S equals 180 times 18 minus 2. If we calculated this as our fourth step, we would find the sum would become 2,880 degrees. Therefore, we've answered our question. A polygon with 18 sides has an interior angle sum of 2,880 degrees. Let's look at our next question. So what is the size of each interior angle of an 18-sided shape? So this time we're looking for what is the individual size of each angle inside an 18-sided shape. So if we already know that the sum is 2,880 from our last answer, therefore if there are 18 angles in an 18-sided shape, the size of each of those angles would simply be 2,880 divided by 18. The total sum of all the angles divided by the amount of angles in the shape. And our solution would become 160 degrees. Now lastly, this is a much more common question. How many sides does a shape with an interior angle sum of 1,800 degrees have? In this kind of question, we would still use our formula and use the knowledge on how to solve a formula to answer it. Step 1. Write your formula. S equals 180 times n minus 2 degrees. On the right hand side, we would complete step 2. Write your values. And in this question, they haven't given us a value for n, but they have given us a value for the sum, or S. So the value I've written next to our formula is S equals 1,800. Step 2. Substitute your values into your formula. So 1,880 equals 180 times n minus 2. Now, using what you know of algebra, we now need to divide both sides by 180 to try to get n as the subject of our formula. So if I divide the left-hand side of our formula by 180, we would get 10. If I divided the right-hand side of our formula by 180, we would simply be left with n minus 2. But I still need to get n as the subject, so you can see that we now need to add 2 to both sides. If I add 2 to the right-hand side, we would simply get n. And if I add 2 to the left-hand side, we would get 12, or 10 plus 2. Therefore, the shape has 12 sides. Now we're going to do many more of these kind of questions in class, and I will help you with your understanding of how to actually change the subject within formulas a little bit better than what you may be feeling you can do at the moment. So, next lesson, we're going to look at something called congruency, specifically within triangles. But I hope you've enjoyed the lesson. Please watch again if any of that was confusing or you need some bit of brush up before you come into class. Have a great weekend, Year 10.